Hello everyone. Today we are excited to present 5G, a world-changing technology. This presentation will delve into the evolution, technical innovations, and social-economic impact of 5G. My name is Yang Yuqiao, and my colleague is Chen Junxi. We will guide you through this transformative journey. Let's begin. This is a table of content. We're going through the introduction of 5G evolution, 5G physical layer, key 5G technologies, and social economic impact of 5G. Let's first introduce 5G. "1G is first developed in the 1980s, brought along voice calls but lacked data capacities. 2G introduced digital voice and SMS, laying the groundwork for mobile data. 3G enabled mobile internet and video calls. It's revolutionizing connectivity. 4G delivered high-speed internet, HD streaming, and IoT. 5G now elevates this with ultra-fast speeds, massive connectivities, and near-zero latency. Each generation reflects humans' relentless pursuit of faster, smarter communication. Then, let's go to 5G physical layer process overview. The 5G physical layer is the backbone of its performance. It involves 4 core steps. First one, transport block generation. Second one, error protection. Third one, LDPC coding and rate matching. And the fourth step, signal processing. Transport block generation starts with selecting a modulation and coding scheme, which is called MCS. MCS balances efficiency and reliability using tables defined by 3GPP standards. Next, we calculate resource elements, REs, based on bandwidth and configuration. Finally, the transport block size is determined using 3GPP formulas shown below. This ensures optimal use of available spectrum. Then, to detect transmission errors, CRC is applied. A generator polynomial like x to the power of 24 plus x to the power of 23, etc., plus x plus 1 is selected. Zeros are appended to data matching the polynomial degree. Modulo 2 division generates a remainder which becomes the CRC checksum. The checksum is appended to original data. This simple yet powerful method ensures data integrity across noisy channels. When data exceeded coder capacity, segmentation is required. Base graph 1 handles block up to 8448 bits. G2 supports 3840 bits. The number of code blocks C is calculated using C equals B over KCB minus L, where L here is equal to 24. Each segments get a 24-bit CRC for error detection. This allows selective retransmission, enhancing efficiency in dynamic networks. LTPC coding uses sparse parity check matrices for robust error connection. Lift size ZC is chosen based on block size. A sparse matrix H is generated for low complexity encoding. Code words are validated by ensuring h times c to the power of t equals to 0. LDPC efficiency makes it ideal for 5G's high-speed, low-latency demands. Rate matching aligns encoded bits with transmission resources. Bit interleaving scatters bits to combat burst errors. A circular buffer stores encoded bits for flexible extractions. Punctuation removes redundancy while repetition duplicates bits for robustness. The dynamic adaptation ensures optimal performance under varying channel conditions. Modulation scheme like QPSK, 16 QAM, and 256 QAM balance speed and reliability. Higher order, for example, 256 QAM pack more data but are less noise resistant. Layer mapping distributes symbols across MIMO layer up to 8 layers. Techniques like spatial multiplexing and diversity schemes maximize throughput and reliabilities. This enables 5G gigabit level speeds and robust connectivity. Antenna port mapping optimizes signal transmission. Direct mapping is simple, while CSI-based mapping adapts to channel conditions. Resource mapping allows logical, which is VRB, and physical, PRB resources. Non-interleaved for sequential allocation. Interleaved for frequency diversity. These strategies balance efficiency and resilience and diverse environments. Then we talk about key 5G technology. Military wave unlocks vast bandwidth, 24 GHz to 100 GHz, for multi-gigabit speeds. The challenge for this is the short range, poor penetration, and sensitive to weathers. The solution to solve this, we come up with ultra-dense networks and beamforming. While revolutionary, its deployment requires careful planning to overcome limitations. Then, massive MIMO uses up to over 128 antennas for 3D beamforming and space division multiplexing. The benefits of this is higher capacity, energy efficiency, and reduces interference. The application of this massive MIMO is the stadium, urban center, and LOT hubs. This technology is cornerstone of 5G's performance leap. UDNs, which is ultra-dense networks, deploy small cells every 10 to 100 meters to achieve 1,000 times capacity gains. The challenge of this method of this technology is interference measurements and energy efficiency, dynamic spectrum sharing, and AI-driven coordination are arised to solve these challenges. UDNs are critical for supporting 5G's promise of massive connectivity. Then we'll talk about economic projections for 5G. By 2035, 5G is projected to contribute 3.5 trillion to global GDP, create 22 million jobs worldwide, enable 13.2 trillion in sales across industries. These figures underscore 5G's role as a global economic catalyst. Also, 5G-enabled applications like smart city, autonomous vehicles, telemedicine, and smart manufacturing. "5G expanded attack surface demand robust security. There are threats and we came up with solutions. The stress involves LT, the expanded attack surface, software-based infrastructure, edge computing, supply chain. And the solution for that is zero trust architecture, continuous monitoring, and secure supply chains. Balancing innovation with security is critical for 5G's success. Today, 5G covers 40% of the global population with over 1.5 billion subscriptions. Leading region includes East Asian, North American, and Europe. However, bridging the digital divide remains a priority for equitable access. Then we'll come to our conclusion. In conclusion, 5G is more than a network. It's a foundation of a connected future. Technically, its physical layer process set new benchmarks. Economically, it drives growth across the industry. Globally, it bridges gap and fuels innovation. The future? 6G, with a focus on sustainability and inclusively. Thank you all for listening. This is all what we share today. Thank you all for listening.